Okay, next example is y equals to sine x minus 1/2 x on 0 to 2 pi. Let's try to draw the graph. First, the derivative, cosine x minus 1/2. And also the second derivative is the derivative of this, which is negative sine of x. Okay, we are interested in the sine of y prime and sine of y double prime, and also the points where these are equal to 0. To find where this is equal to 0, we need to solve this trigonometric equation. Negative 1/2 can be moved over here, and you get 1/2 equal to cosine of x. So basically, you're trying to find the points, the x values, where the value of the cosine is exactly equal to 1/2. Now, to do that, you need to remember the graph of the cosine. So here's 2 pi. Half of it is pi. Half of pi is pi over 2. Between pi and 2 pi, the midpoint is 3 pi over 2. That's because if you add pi plus 2 pi, that's 3 pi, and if you average it, you have to divide by 2. So that's the midpoint. Now on here, the graph of the cosine is blue, starts from 1, passes through here, goes up. So that's the graph. Use the red. So it starts from 1, 0, negative 1, 0. So that's the graph of cosine of x. Then you have to remember that between 0 to 90 degrees, this pi over 2 is 90 degrees. Between 0 to 90 degrees, there are 3 places where you know the exact value of cosine. Right? There should be like, for each of these, you have 3 values where you know the exact value of. And we're interested in this because one of them is 1/2, right? So do you remember those values? It's they all look like this, right? And we have a nickname for that. It's small, medium, large. Right? 1, 2, 3. It's easy to remember. It's just 1, 2, 3. And because here, this is the large one, that's the medium one, and this is the small one. And look, this is just 1/2, right? Square root of 1 is 1, so it's 1/2. So this right here, this small one here, is the one that we want to look for. That's 1/2. And same here. Small, medium, large. The small one is the 1/2 value. Okay. So now tell me, what's the angle here? First, tell me in degrees. What is this angle? 30, 45, 60. So which one is it? 60 degrees. So we know that cosine of 60 degrees, or in terms of radians, what is that? Pi is 180. If you divide 180 by 3, you get 60, right? So cosine of pi over 3 is 1/2. Now, next is sine of something here. Right? Let's see, this is 270 degrees. And you add 30, 45, 60 to 270 degrees to get these angles, right? So what is this angle that we're interested in? In degrees, 270 plus 30. 270 plus 30 is 300. Okay, 300 is 5 times 60 degrees, right? So it's 5 times this thing. Why did I write sine? Sorry, I meant to say cosine. Cosine of 300 degrees is 5 times pi over 3, and that's equal to 1/2. So we know that the y prime will be equal to 0 at x equals to pi over 3 and 5 pi over 3. Okay. Now for y double prime, we're looking for the case where negative sine x is equal to 0. That means we're looking for the place where sine x is equal to 0. Excluding the endpoints, by the way. We want to know the signs inside. So now we will have to draw the graph of the sine curve. Okay, let's do the same thing. 2 pi, half of 2 pi is pi, half of pi is pi over 2. Add pi plus 2 pi, that's 3 pi, but we're taking the average, so you have to divide by 2. So those are the 4 points that you have to know. For the sine, the curve looks like this. That's the sine graph. Now, when is it equal to 0? Here, here, here. Every time it passes through the x-axis, that's when sine becomes 0. But 0 and 2 pi are the endpoints, and we're not interested in there because we really want to know when the sign changes. So the only place that we have to consider is x equals 2 pi. So that's the place where there could be a change in concavity because the y double prime changes.
Doctor?
Yes?
If there's square brackets, why are you excluding the...
Because the reason that we're trying to figure out the places where it's 0 is because we want to, so it's like this, 0 pi, 2 pi. We want to pick a test point here and there, right? So pick a value here, pick a value here, but we don't want to pick a value after this. We don't, it's equal to 0. So, I mean, I guess it's good to know it's equal to 0, but for our consideration, it's not one of the inflection points. Yeah. There should be a sign change before and after. Well, since we have this first, let's just pick some book values here. Okay. So I guess the easy values to pick between them is, say, let's pick pi over 2 and 3 pi over 2 as test values for y double prime. Okay, what's negative sine of pi over 2? First, what's sine pi over 2 according to this graph? Sine pi over 2 is? 1, right? So if you put a negative in front, you get negative 1, which means it's negative. So y double prime is negative. 3 pi over 2. At 3 pi over 2, sine gives you the value of? Negative 1. And if sine is negative 1, negative of negative 1 is positive 1. So it's going to be positive. So that we know. Now let's try to work with cosine. Here is 0. Here is 2 pi, and here's pi over 3, and here's 5 pi over 3. And we have to pick test values. Now, I want to pick 0 as the test value, and 2 pi as the test value. Now, when you're picking the boundary values as the test value, one thing that you have to be careful is that you have to make sure that the boundary values is not one where it gives you 0. Okay? If it gives you 0, you can't tell whether this interval will be positive or negative. But as long as it's not equal to 0, the sign of the derivative at this point will determine the sign of the entire interval. So it's okay to pick these if it doesn't give you 0. And I want to take that risk because 0 and 2 pi are very easy to compute. And also, I want to pick pi because that's another easy value to compute. Okay. Now, what's cosine of 0 according to this graph? 1. Okay. If cosine of 0 is 1, what would you get if you plugged in here? 0 minus 1/2. What does that give us? No, not 0. 1 minus 1/2. What does that give us?
1/2.
1/2, so it's positive, right? So it's going to be positive here. What's cosine of pi, according to this graph?
-1.
Negative 1. Negative 1 minus 1/2. Negative or positive? Negative. So it's positive here, negative here. And then when you plug in 2 pi, cosine 2 pi is again 1. It's the same value as before. before, 1 minus 1/2 is still positive. So that's what we know about y. Now, since this graph is just on a finite domain, you can't have asymptotes. Asymptotes are the behavior as you go to the right or left, but it's bounded, so there's no need for thinking about asymptotes here, horizontal asymptotes here. And also, this function is defined for all values, and all the values are finite, right? If all the values are finite, then there's no way you can go to positive infinity where we have to worry about vertical asymptotes. So there's no asymptotes for this one. Finally, let's try to figure out the x and y intercepts. Okay, so let's see. I'm not so sure. Yeah, I'm not so sure if I can find the. Okay, first of all, y-intercept. That means I have to plug in 0, sine of 0 minus 1/2 times 0. Sine of 0 is, according to this graph, 0. Right? Sine of 0 is 0, and if you plug in 0, it's 0, so it's going to be 0. For the x-intercept, you have to say 0 equals to sine x minus 1/2 x. And I'm not so sure if I can solve this. So to give you an idea, let me show you what this means. This is a intercept between two graphs, right? You have y equals to 1/2 x and y equals to sine x. You have two graphs. That's if you want to find the. Let's say you have two graphs, y equals to 1/2 x and y equals to sine x. And if you want to find the point of intersection, what do? You set them equal to each other. Right? That's how you would get this. So to picture the point where this is true, you have to draw the graph y equal to 1/2 x, which is like this one. And that's, I don't think you can solve that algebraically. So it does exist. It passes at some point, somewhere between pi over 2 and pi, but I guess we can't figure it out. So let's just leave it like that. It's going to pass through it. I don't know it. Okay, now also we have to find the value, y value at pi over 3, 5 pi over 3, and also at pi, because those are the relative, this will be relative max, this will be relative min, this will be an inflection point. So we want to find the coordinates of those. Okay, so relative max, y equals to sine of pi over 3 minus 1/2 times pi over 3. Sine pi over 3, according to this graph, see, small, medium, large, right? So what's the value of sine pi over 3? It should be one of these three values, small, medium, large. Pi over 3 in degrees, what is it? 60 degrees, and these are what? 30, 45, 60. Okay, so is it small or medium or large?
Large.
It's the large value, right? So it should be radical 3 over 2. And then when you multiply a fraction top to top, bottom to bottom, so it's pi over 6. Now, to give you some idea of what's going on here, this is like radical 3 is 1.7 divided by 2, so it's about 0.85 something. Pi is about 3, so this is like 0.5. So 0.85 minus 0.3, that's 0.5, about 0.3. It's a slightly big. It's just slightly bigger than 0. Okay, now relative min, y equals to sine of 5 pi over 3 minus 1/2 times 5 pi over 3. Okay. Let's go over here. 5 pi over 3 is this one. So it's negative rad 3 over 2. And this will be 5 pi over 6. So it's going to be some negative value. And finally, for the inflection point, you have pi x equals to pi, so if you plug in there, y equals to sine of pi minus 1/2 of pi, and sine of pi is, according to this graph, 0, so it's negative 1/2 pi. So now we can put all of those together to draw the graph. Okay, so between 0 to pi over 3, we know that y prime is positive. What about y prime? Y double prime? On here, what do you see? It's before pi, so it's negative. Between pi over 3 to pi, y prime is negative and y double prime is negative. Between pi to 5 pi over 3, y prime is still negative, but after pi, y double prime becomes positive. And then after 5 pi over 3, and before 2 pi, y prime becomes positive, and this is still positive. So that takes care of these two findings here. So let's just erase it. And then we know that it should pass through 0, 0, passes 0, 0. And it has some x-intercept. We don't know the exact coordinates. It also passes pi over 3, comma, radical 3 over 2 minus pi over 6. 5 pi over 3, comma, negative radical 3 over 2 minus 5 pi over 6. And then also there's an inflection point at pi, comma, 1/2. So that contains all the information that we found over here. Let's draw the graph now. So passes 0, 0. At pi over 3, it's some small positive value. At pi, so this is pi over 3. At pi, it's 1/2 pi. Right. No, something's not right. Oh, it should be a minus. Did I put a minus? No, that's not right. It's plus.
No, it should be.
Yeah, it's a negative 1/2 pi.
Oh, it's minus. Oh, yeah. Sure. It should be minus. Okay. Something was wrong. So it should be minus. So it's over here. Let's just say this is 1/2 pi. And then at 5 pi over 3, 5 pi over 3, here's 2 pi. Because it's going to be decreasing continually, it has to be going down somewhere. So we don't know the exact value of this, but it's still somewhat less than this point. Okay? So that's what we know. These are the points. And then let's figure out the behavior of y. Y increases where it bends like that. It's a, see, y double prime being negative means it's a frowning face, right? And if y double prime is positive, it's a smiley face. So if it's increasing and y double prime is frowning, it's like the left side of this frown, just like this. So you can look at this and figure out the shape just by looking at this diagram. Okay? Negative, negative, so it's decreasing and still frowning, so it's this part, decreasing and frowning. This is decreasing and smiling, right? Decreasing and smiling means this left side here. And increasing and smiling should be that side. Okay, so that's how we should connect these. So from here to there, I should have that way of bending. From pi over 3 to pi, it should be bending like this. And from pi to 5 pi over 3, it should be bending like that. And from 5 pi over 3 to 2 pi should be bending like this. And it might be helpful to know that at 2 pi you have the value of negative pi. So that's the graph. Okay, so we did a lot of work to figure out all this, but however, if you really didn't need to know the position of the inflection points nor the coordinates of the relative extrema, then there's actually an easier way to figure out what's going on. So think about this. This is the sum of y equals to sine x, whose graph is like this. So this is the graph of y equals to sine x, right? Now, what's the graph of y equals to negative 1/2 x? It's like this. Right? It's a decreasing line. And the question is, what would you get if you added these two values together? Then you can kind of see that it's going to be having the shape, but it's like somehow this is placed upon an incline. So everything shifts down as you go right. So if you add these two together, then you end up with something that's like this, but it climbs down as you go right. So if you extended this, it'll be like this. So it'll be I mean, if you drew this on negative infinity to positive infinity, you'll be seeing a sine graph that's not going horizontally, but as you go right, it's going down. That's why the portion of the graph should look like that. Okay? So that will be another way to think about the graph.